My name is Kamilah Todd, and I'm going to use state school district data to determine if there's a significant difference in, in enrollment between Regions 1 and Regions 5. First, we're going to test assumptions using a histogram. So to do that, you're going to go to Data, go down to Select Cases, and we would like to test if condition is satisfied for region. We click on region and move that over, hit equal, and we're looking at region 1. Hit continue. Okay. Then you're going to go to analyze, descriptive statistics, frequency. We're going to look at enrollment, move that over, go to charts, and we would like a histogram to check to see if the data shows a normal bell curve. So we're going to check that box to show normal curve on histogram, continue, and OK. Again, frequency. There we go. So you see in this sample for region 1, there are 72 entries, and it does not pass the test of assumptions. It does not have a normal bell-shaped curve. So now we're going to test region 5. So we go back to data, select cases, if conditions satisfied, and we want to change that to region 5. Continue. Okay. Then we proceed to analyze descriptive statistics and go to frequencies. It's already selected for enrollment. We'll check charts. Again, it's a histogram, and we're looking for the normal curve. Hit continue and OK. Now there are 23 in this sample, 23 entries. It does pass the test of assumptions if we're just looking at it as a single region. It makes a normal bell-shaped curve. But we were looking for both regions to pass the test, and region 1 doesn't. But we're going to assume that it does, and we're going to proceed to an independent sample t-test to check for variance. So I'm going to go back to my original data so I can clear the filter. So we're going to select and hit delete so that we can look at all data. Then we're going to go to Analyze, go to Compare Means, and go down to Independent Sample t-test. And our variable is enrollment. Our grouping variable are regions 1 and 5. So when we define our groups are 1 and 5. We hit continue. We do want to do a homogeneity of variance test so we can see if there is variance and then also how significant that may be. And we hit OK. And we see that regions 1 and 5, both data sets are included here. There's a mean for region 1, 2,353, a mean for region 5 at 987. We're going to look at equal variances being assumed, and we could see that here it has a significance of 0.054. So the p-value is 0.054. We're looking specifically for the Levine test, and we want a significance that's greater than 0.05. And here we see that we have a significance that is less than 0.05. Our significance for the Levine test is 0.01. So we will reject the null hypothesis that there is a significant difference between regions 1 and 5. Now, our Cohen D value will tell you what level of significance it is, since we've already determined that it isn't a large difference. And our Cohen D value is 0.389. And if we're following standard Cohen D for if it's a small, medium, or large difference, small being a value of 0.2 or less, medium being a value of 0.5, but more than 0.2, and large being a value of 0.8 or greater. So in this case, 0.389 falls in between the 0.2 small and the medium 0.5. So the level of significance is not great.